Firefly Aerospace's Blue Ghost Mission 1, a historic lunar landing. Overview. Firefly Aerospace's Blue Ghost Mission 1 is poised to make history as the company's first lunar landing scheduled for March 2, 2025. This mission, a part of NASA's Commercial Lunar Payload Services (CLPS) program, has been allocated a budget of $101.5 million to deliver 10 scientific payloads to Mare Crisium, a significant site on the Moon's surface. The mission aims to support NASA's Artemis program, which is focused on returning humans to the Moon and establishing a sustainable presence there. Launch and journey. The Blue Ghost lander was launched on January 15, 2025 aboard a SpaceX Falcon 9 rocket. The launch marked the beginning of a nearly 45-day journey to the Moon. Once in space, the lander will complete a series of maneuvers including Earth orbit and lunar transfer, followed by adjustments for a soft landing. The anticipated landing time is around 2:34 a.m. Central Standard Time on March 2, 2025. Upon arrival, Blue Ghost will operate on the lunar surface for approximately 14 Earth days, which corresponds to one full lunar day. During this time, it will conduct scientific research and validate various technologies that are crucial for future lunar exploration. Mission objectives and payloads. The primary goal of Blue Ghost Mission 1 is to deliver 10 scientific and technological payloads designed to advance lunar research. These payloads include 1. Lunar PlanetVac. This instrument will collect regolith samples, providing insights into the lunar soil's composition. 2. Lunar GNSS receiver experiment aimed at improving navigation technologies for lunar missions. 3. Electrodynamic Dust Shield, a technology designed to mitigate the challenges posed by lunar dust. 4. Lunar Environment Heliospheric X-ray Imager LEXI, developed by Boston University and NASA. This instrument will study solar-wind interactions with the Moon's surface. 5. Lunar Magnetotelluric Sounder LMS. This payload will investigate the Moon's magnetic fields. 6. Radiation-Tolerant Computer RAD-PC, to test computing systems capable of withstanding harsh lunar conditions. 7. Next-Generation Lunar Retroreflector NGLR, created by the University of Maryland. This will enhance lunar positioning systems. 8. Regolith Adherence Characterization RAC, investigating how lunar dust adheres to surfaces. 9. Stereo Camera for Lunar Plume Surface Studies SCLPSS, designed to study the interaction between lunar dust and other surface materials. 10. Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity Lister, aimed at probing the Moon's thermal characteristics. These payloads are vital for understanding lunar conditions and phenomena, which will aid in the preparation for future crewed missions under the Artemis program. Significance of the landing site. Blue Ghost will land in Mare Crisium, a large basin formed by ancient volcanic activity. This site is particularly interesting for scientists because it offers the opportunity to study the Moon's regolith and its geophysical characteristics, as well as the interactions between the solar wind and the Moon's surface. The choice of this landing site reflects the mission's goals of advancing our understanding of the Moon's history and environment. Mission timeline. The mission operates on a detailed timeline of events. January 15, 2025, launch from Earth via Falcon 9. March 2, 2025, scheduled landing in Mare Crisium at approximately 2:34 a.m. Central Standard Time. March 14, 2025, expected capture of high-definition imagery of a solar eclipse as the Earth obstructs the Sun from the Moon's horizon. March 16, 2025, observation of a lunar sunset, contributing to studies of lunar dust behavior. Technical features of the Blue Ghost lander. Firefly's Blue Ghost lander is designed for stability and reliability. It features shock-absorbing legs, to enhance stability during landing. Advanced materials, commonly used in Firefly's launch vehicles, which provide strength while reducing weight. Navigation capabilities, equipped with vision-based terrain navigation to identify a safe landing zone during the final descent. Communication systems, multiple antennas for robust communication and high-definition video transmission back to Earth. Future implications. If Firefly Aerospace successfully completes this mission, it will become the second private U.S. company to land on the Moon, following SpaceX. This achievement will not only enhance Firefly's reputation in the space industry but will also contribute to the growing landscape of commercial space exploration. The data collected from the mission will support ongoing lunar research and lay the groundwork for future missions aimed at establishing a sustained human presence on the Moon. Conclusion. Firefly Aerospace's Blue Ghost Mission 1 represents a significant step forward in lunar exploration. With its scheduled landing in Mare Crisium, the mission aims to deliver vital scientific data and technological advancements that will support both current and future lunar endeavors. As humanity continues to look toward the Moon as a stepping stone for further exploration, missions like Blue Ghost play a crucial role in unlocking the secrets of our nearest celestial neighbor. The world will be watching closely as this mission unfolds, with the hope of paving the way for a new era of lunar exploration and discovery. Counterintuitive information in Firefly Aerospace's Blue Ghost Mission 1 content. 1. Funding and commercial space exploration. The Blue Ghost Mission 1 is funded by NASA's Commercial Lunar Payload Services (CLPS) program for $101.5 million. This might seem counterintuitive, as one might expect private companies to solely fund their missions. However, this reflects a shift in the space industry where government agencies are increasingly collaborating with private sectors, creating a symbiotic relationship that allows for reduced costs and accelerated innovation. 2. Mission duration. The mission is set to operate for about 60 days, including only 14 days of actual surface operations on the Moon. This might be surprising, as many may assume that a lunar mission would have extended operational periods on the surface. The limited duration is dictated by the harsh lunar environment, particularly the extreme temperature fluctuations and solar radiation, which make prolonged surface operations challenging. 3. Payloads and their impact. Among the payloads, there are instruments for advanced lunar research, including the Electrodynamic Dust Shield designed to mitigate lunar dust. This can be counterintuitive because one might think that lunar dust is merely a nuisance. However, it poses significant challenges to both landers and astronauts. Dust can damage equipment and affect human health, making its mitigation a critical aspect of lunar exploration. 4. Landing site selection. The chosen landing site, Mare Crisium, is near a volcanic feature called Mons Latrell. It might seem surprising that a volcanic region is selected for landing, since volcanic terrains can be associated with instability and hazards. However, this site provides valuable scientific opportunities to study lunar geology and the interaction between solar wind and the Moon's surface, showcasing a deliberate choice for scientific exploration over safety. 5. Technological validation. The mission plans to validate technologies such as the Lunar GNSS receiver experiment for navigation on the Moon. It might seem counterintuitive to conduct navigation experiments on the Moon when terrestrial GPS is widely available. However, lunar navigation presents unique challenges due to the Moon's lack of an atmosphere and existing navigation systems, making this validation crucial for future missions. 6. Commercial versus government missions. Firefly will become the second private U.S. company to land on the Moon, which challenges the common perception that only government agencies can successfully conduct lunar missions. This reflects the evolving landscape of space exploration, where private enterprises are becoming key players and the distinction between commercial and governmental missions is increasingly blurred. 7. Role of NASA in the mission. While NASA is funding the mission, it is not conducting the mission directly. This might seem unconventional for those accustomed to viewing NASA as the primary agency for space exploration. It illustrates a broader strategy where NASA acts as a facilitator and partner rather than the sole operator, promoting innovation in the commercial sector. 8. Scientific objectives versus commercial goals. The mission's primary goal is scientific research and technology validation, which might seem at odds with the commercial objectives of a private company. However, the success of such missions can lead to commercial opportunities in lunar exploration, indicating that scientific and commercial interests can align rather than conflict. 9. Public engagement via live streams. The mission will include a live stream of the landing and significant events, which is not typical for previous space missions primarily orchestrated by government agencies. This approach challenges the traditional narrative of space exploration as an exclusive domain for scientists and engineers, instead promoting public engagement and interest in space science. 10. Transition from Earth to lunar operations. The Blue Ghost will spend nearly 45 days traveling to the Moon before landing. This extended travel time may seem inefficient compared to the rapid transit times of crewed missions in the past. However, this slower, more deliberate pace allows for thorough health checks on systems and ensures all instruments are functioning properly before lunar operations begin. Each of these points highlights the nuanced dynamics of modern lunar exploration, where collaboration, technological challenges, and scientific goals intersect in unexpected ways. Firefly Aerospace's Blue Ghost Mission 1 represents a pivotal moment in the evolution of lunar exploration, particularly as it intersects with NASA's Commercial Lunar Payload Services (CLPS) program. The mission is scheduled for a lunar landing on March 2, 2025 in Mare Crisium, an area characterized by its geological significance due to volcanic features. The mission's funding of $101.5 million is indicative of NASA's trust in private industry to contribute to space exploration, marking an important step in the commercialization of space. Key aspects often overlooked. 1. Geological significance of Mare Crisium. While many reports emphasize the mission's technological and operational aspects, the choice of Mare Crisium as the landing site is critical yet understated. This lunar mare is not just a flat plain, it is believed to contain volcanic deposits that could provide insights into the Moon's geological history and the processes that shaped its surface. Studying these materials could yield valuable information about the Moon's formation and its volcanic activity, which is essential for understanding the broader dynamics of terrestrial planetary bodies. 2. Scientific payloads and their implications. The mission will deliver 10 scientific payloads, including the Lunar PlanetVac for regolith sample collection and the Lunar GNSS receiver experiment for navigation. While the technological capabilities of these instruments are highlighted, the significant scientific implications are often glossed over. For instance, the regolith samples could help in understanding lunar soil properties, which is critical not only for future human habitation but also for in situ resource utilization (ISRU) strategies. This could enable sustainable human presence on the Moon, a key goal of NASA's Artemis program. 3. Technological validation. The mission is designed to validate several technologies such as the Electrodynamic Dust Shield (EDS) and radiation-tolerant computing systems. Many discussions about the mission focus on the payloads, but the technology validation aspect is crucial for future missions. The success of these technologies could lead to advancements in lunar dust mitigation, which presents a significant hazard to both robotic and human operations on the Moon. The EDS, for instance, could play a critical role in protecting sensitive instruments from the abrasive lunar dust, a challenge that has plagued previous missions. 4. Collaborative efforts across institutions. The involvement of various institutions and partnerships for payload development is a noteworthy yet often overlooked detail. This collaboration exemplifies the collective effort required in modern space exploration, where the integration of expertise from diverse fields enhances mission outcomes. The partnerships with universities and organizations like the Italian Space Agency and Boston University signify a shift towards a more inclusive approach in space science, enabling innovation through shared knowledge and resources. 5. Potential for long-term lunar presence. The mission is not just about a single landing, it embodies the groundwork for sustained lunar exploration. If successful, Firefly Aerospace will become the second private U.S. company to land on the Moon, which could inspire further commercial ventures. The implications of establishing a routine lunar transportation and research capability cannot be overstated. This could lead to a new era of exploration where lunar resources are utilized for deeper space missions, potentially including Mars exploration. 6. Environmental and Earth science implications. The mission aims to provide insights that extend beyond lunar research. For instance, understanding how solar wind interacts with the Moon's surface can inform us about cosmic phenomena that also affect Earth. The Lunar Environment Heliospheric X-ray Imager LEXI payload particularly underscores this connection. The data collected could enhance our understanding of space weather, which is crucial for satellite operations and communications on Earth. Conclusion. Firefly Aerospace's Blue Ghost Mission 1 stands as a significant milestone not only for the company but for lunar exploration as a whole. While the mission's objectives, timeline, and technology are highlighted, the nuanced implications of site selection, payload capabilities, collaborative efforts, and the long-term vision for lunar exploration are often overlooked. These aspects are crucial for understanding the broader impact of this mission on humanity's return to the Moon and the establishment of a sustainable presence there. As we move towards an era of commercial space exploration, the lessons learned from this mission will likely influence future endeavors in both lunar and planetary exploration. 1. Significance of the Blue Ghost mission in lunar exploration. The Blue Ghost Mission 1 is pivotal as it represents Firefly Aerospace's first attempt at a lunar landing, potentially making it the second U.S. private company to achieve this milestone. Funded by NASA through the CLPS program, this mission not only supports the Artemis program's goal of returning humans to the Moon but also sets a precedent for future commercial lunar exploration. The choice of Mare Crisium as the landing site, a region with volcanic features, underscores the mission's scientific value, allowing the study of lunar soil and geological characteristics that could inform future human landings and resource utilization. 2. Payloads and technological innovations. The mission's delivery of 10 scientific payloads highlights the integration of advanced technologies and scientific research aimed at enhancing lunar exploration. Key instruments like the Lunar PlanetVac for regolith sample collection and the Electrodynamic Dust Shield for dust mitigation are particularly notable. These technologies not only address challenges faced during lunar missions such as dust accumulation on equipment but also provide opportunities for in-situ resource utilization, which is crucial for sustained human presence on the Moon. 3. Operational design and capabilities of the Blue Ghost Lander. The design of the Blue Ghost Lander emphasizes stability and reliability, featuring a low center of mass and shock-absorbing legs capable of withstanding the harsh lunar environment. The lander's advanced navigation system employs vision-based terrain relative navigation for safe landing, which is essential for future missions where precision is paramount. Additionally, the use of flight-proven technologies from Firefly's launch vehicles enhances cost efficiency and operational reliability, making it a model for future lunar landers. For her broader implications for space exploration and collaboration, the collaborative nature of the Blue Ghost mission, involving multiple institutions and leveraging NASA's commercial lunar payload services, reflects a growing trend towards public-private partnerships in space exploration. This model not only fosters innovation but also democratizes access to space, allowing a broader range of organizations to contribute to lunar science. The mission's success could pave the way for more commercial endeavors in space, ultimately leading to a sustainable human presence on the Moon and beyond, which aligns with global exploration goals and international collaboration in outer space. 1. Lunar Module Apollo 11 Mission. On July 20, 1969, NASA's Apollo 11 mission achieved a historic milestone as it marked the first successful manned lunar landing. Astronauts Neil Armstrong and Buzz Aldrin piloted the lunar module named Eagle to the surface of the Moon in the Sea of Tranquility, while Michael Collins orbited above in the command module. This mission set the stage for future lunar exploration and demonstrated the feasibility of human space travel beyond Earth. Armstrong's famous words, "That's one small step for a man, one giant leap for mankind," symbolized the monumental achievement in human history and space exploration. 2. Lunar landers Chandrayaan-2. India's Chandrayaan-2 mission, launched on July 22, 2019, was a significant step for India's space program aiming to explore the Moon's south polar region. The mission included an orbiter lander Vikram and rover Pragyan. Although Vikram experienced a hard landing on September 6, 2019, the orbiter continues to successfully transmit valuable data about the lunar surface, such as mineral composition and the presence of water ice. The mission underscored India's growing capabilities in space exploration and laid the groundwork for future lunar missions. 3. Surveyor program Surveyor-1. The Surveyor-1 spacecraft, launched by NASA on May 30, 1966, was the first successful U.S. soft landing on the Moon. It landed in the Ocean of Storms on June 2, 1966, and provided critical data and images of the lunar surface, which were essential for planning future Apollo missions. Surveyor-1's findings confirmed that the lunar soil could support the weight of a spacecraft, contributing to the design of the Apollo lunar module. The Surveyor missions played a crucial role in advancing lunar science and technology ahead of human exploration. Firefly Aerospace's Blue Ghost Mission 1 is set to make significant strides in lunar exploration when it lands on March 2, 2025 at Mare Crisium, supported by NASA's Commercial Lunar Payload Services (CLPS) program. This mission, funded with $101.5 million, is part of the Artemis program aimed at returning humans to the Moon and establishing a sustained presence. The successful landing of Blue Ghost will mark Firefly as the second U.S. private company to achieve a lunar landing, opening avenues for future commercial lunar exploration. Future outlook for lunar exploration. 1. Commercial lunar missions expansion. The success of Blue Ghost Mission 1 is likely to boost confidence in commercial lunar missions. More companies will likely enter the lunar exploration arena, driven by advancements in technology and decreasing costs. This will lead to increased competition, innovation, and a variety of mission profiles, including resource mining, scientific research, and tourism. 2. Technological advancements. The Blue Ghost mission is designed to validate several key technologies for lunar exploration, such as advanced navigation systems, regolith sample collection, and dust mitigation techniques. Successful demonstrations could pave the way for the development of more sophisticated landers and rovers, enhancing our ability to explore and utilize lunar resources. This could also lead to improvements in Earth-based applications such as robotics and autonomous systems. 3. International collaboration. With the increasing interest in the Moon, international partnerships are likely to become a cornerstone of future lunar missions. Countries with ambitions for lunar exploration, including India, Japan, and European nations, may collaborate with private companies to share technology, data, and resources. This cooperative approach could result in more comprehensive exploration efforts and a unified strategy for sustainable lunar presence. 4. Artemis program progression. The Blue Ghost mission is a critical step towards NASA's Artemis program, which aims to land humans on the Moon by 2024 and establish a sustainable presence by the end of the decade. The data collected from Blue Ghost will be invaluable in preparing for crewed missions. Successful scientific payloads could lead to further missions focused on specific scientific inquiries, such as understanding lunar geology and assessing potential resources like water ice. 5. Sustainability and resource utilization. As lunar exploration progresses, there will be a greater emphasis on sustainability and in situ resource utilization (ISRU). Future missions will likely focus on harvesting lunar resources such as water ice for life support and fuel, and utilizing lunar regolith for construction. Blue Ghost's payloads could provide critical data to inform these efforts, contributing to a self-sustaining lunar base. 6. Long-term human presence. The eventual goal of lunar exploration is establishing a long-term human presence. Successful missions like Blue Ghost will contribute to our understanding of the lunar environment, supporting the development of habitats, life support systems, and technologies needed for sustained human activity. This foundation could facilitate deeper exploration of Mars and beyond. 7. Scientific discoveries. The scientific instruments aboard Blue Ghost are designed to study various lunar phenomena, including the interaction of the solar wind with the Moon's surface and the characteristics of lunar regolith. The insights gained could lead to breakthroughs in our understanding of not only the Moon but also planetary science as a whole. Discoveries made on the Moon may provide clues to the early history of our solar system. 8. Public interest and inspiration. With missions like Blue Ghost capturing public attention, interest in space exploration is likely to grow. This could lead to increased funding for space initiatives and inspire a new generation of scientists, engineers, and explorers. Educational outreach and public engagement activities associated with these missions will be crucial in maintaining this momentum. Conclusion. Firefly Aerospace's Blue Ghost Mission 1 represents a pivotal moment in the landscape of lunar exploration. If successful, it will set the stage for an era marked by commercial endeavors, international collaboration, and scientific breakthroughs. The mission's outcomes will likely influence the trajectory of lunar exploration for years to come, moving humanity closer to a sustained presence on the Moon and ultimately beyond.